In this video, I'm going to talk about implicit differentiation. So basically, implicit differentiation is when we are given an equation that has x in it, but it also contains another variable like y, but y is just an implicit function of x. And what I mean by this is if we're given something like x cubed plus 3 plus y squared equals to 7x, how would you differentiate this? Because you're used to seeing something like, okay, y is equal to 2x, or f of x is equal to 2x, right? Well, this time we're given two variables within our equation, and one of those variables is y, and y just happens to be an implicit function of x. So basically, to do this, we need to differentiate both sides of the equation and solve for our what comes out of our y variable here through the chain rule. So let's start with differentiating both sides of the equation. So we're going to differentiate the right side of the equation, and we're also going to differentiate the left side of the equation. So let's start with our first term here, x cubed, and that's the derivative of x cubed is 3x squared from the power rule, right? We bring down the power, then subtract the power by 1. Our next term is 3, and 3 is a constant, so the derivative of a constant is 0. And our next term is y squared. So let's take the derivative of y squared, and that's 2y from the power rule, but we're not done yet. Since this is an implicit function of x, we have to account for that, and we have to use the chain rule. So anytime you see a y term here, and you're doing implicit differentiation, you're going to take the derivative of that y term, just how you would take any derivative, right? You use the rule set, but you're going to multiply that y term by dy, so the derivative of y, with respect to x. And this accounts for our implicit function. And next, we're going to take the derivative on the other side of the equation. So we did the left side right here, and now we need to do the right side. So on the right side, it's just 7x, so the derivative of 7x is 7. Now, we're still not done. This looks a little messy, right? In order to find the derivative of an equation where you're given two variables, x and y, where y, or x, one of them, is an implicit function of the other, you have to take the derivative of both sides, but then after that, this dy dx term that's multiplied to our y variable here, you have to isolate it, you have to solve for it. So let's do that. So dy over dx equal to, we had 7 on the right side already. Next, we're going to move our 3x squared on the right side, so minus 3x squared. And we're also going to divide by our 2y here. Right, we have 2y on this side attached through multiplication, so we divide it on both sides, and it cancels on the left side, and on the right side we get 2y. And that's how you do it. So step 1, differentiate both sides of the equation. Well, of course, step 1 is to figure out that you need to use implicit differentiation. Even though it's called implicit differentiation, it's hidden. The questions are very noticeable. They look a lot different from your normal derivative questions because you're going to see a y term in there, or even a couple y terms in your equation, and it's going to send alarm bells ringing in your head there saying implicit differentiation. So once you figure out that you have to use implicit differentiation, you take the derivative of both sides, you take the derivative of the y term. So I'm going to put, as an example, y squared And then when you take the derivative of the y term, you must multiply the y term by dy over dx. Then step 3 is solve or isolate for dy over dx. Step 4 is happy. You're done. Once you solve for dy over dx, you're finished the question. And that's how you do implicit differentiation. Thanks for watching this video. Like, subscribe, watch another video. Have a great rest of your day.